An educative a day keeps unemployment away. We are dealing with a task scheduler today, and it's a lot of lingo, but I will use this diagram to explain it. We have tasks, and they have a cooldown period before you can see the same task. So n equals 2 means after A, before I can see A again, there needs to be 2 slots between it. So our job is to get the minimum number of units of time it takes for all these tasks to be done, factoring in the fact that if a task is done, it needs two different or empty slots between the next time you see the task. That's why you have A, n is 2. So you have, we put B, then there's an empty slot before we see A again. We can't have A here. And then we count the minimum amount of time it takes for all the tasks to be done, and we get 5 because there's no way around having this idle time here. Similarly with B, and it's similar with B, where you must wait 2 slots before you see another B. So our job is to do that. This has more characters, and we see the same thing. N is 3, so if I see A, I need to have 3 slots before I see A again. Same with B, I need 3 slots before I see B again. And in this case, we had run out of tasks, so we had to have 2 idle slots before we saw A. Then you count this, and you get 9 as the unit of time, the minimum amount of time it takes to complete all the tasks. Let's look at another example. So this is 0, so there's no cooldown time required. So these tasks can be done as is without any change, and we get 4 as the minimum amount of time we need to get all these tasks done. I think that's clear enough where I don't need to run through this quiz. But in this case, for example, yeah, it's hard to see. I think the pictures make it easier to understand. This is the recipe, but what's more important or what's better is seeing the code and the solution actually. And since what we're returning is a number, the minimum amount of time it takes to run through these tasks, factoring in the cooldown period. We have all this lingo, so much explanation, a lot of stuff, but I think this explains it well. We have to keep track of a formula, basically. This formula here, keep track of the idle time required in a given a set of tasks, and this formula is important. We don't derive it, but you can see how you can kind of intuit how it's useful, because we need to store a frequency of the number of times a character appears in a list of tasks. And we do that with a map or a hash map. And we need to keep track of the idle time, how often characters appear, like the maximum amount, the character that appears most frequently, how often it does, and the current frequency for the character we're considering. Let's step through this diagram. So pardon the word salad. So find the minimum number of units of time that the CPU will take to perform the given tasks. So these are our tasks. They are represented by different letters. And then there's a cooldown period of 3. So here's what we're going to do. Create a hash map, store all occurrences of each letter. Iterate through the tasks, count the occurrences of each unique task stored in a frequency map. That's what we're doing. M appears 3 times, A 3 times, B 2 times, Y once. And sort them, which we've done. Maximum frequency is 3. So you can visualize the idle time, and that's not part of our task. Our task is not even to arrange or visualize, but to return the minimum amount of time it takes to get these tasks done. Each one of these represent 1 unit of time. And then this is the cooldown period, 3 units of time before the same task should show up twice. So it can be visualized like this, for example. So first thing we do is calculate the maximum idle time, And you can get that from the frequency that most occurs, less 1 times the rest time, the cooldown period. So this is best case, right? How M needs to be spaced out for it to work with this cooldown period. This is the best case. Now we have the maximum idle time. We know it's 6. Next we need, and let's see, you can count 6 idle periods. 1, 2, 3, 4. Next we need to calculate the idle time. So that's gonna be the former idle time, which in this case is 6, minus the minimum between the maximum frequency and the current frequency. Because we're evaluating A right now, that's the current frequency, which is 3 as well. So the minimum of 3 minus 1, or 3, which gives us 4, because this evaluates to 2. So 6 minus 2 gives us 4. Keep track of the idle time. And you can visualize it like this. The task doesn't involve us visualizing it, but it helps to understand. And you notice that A is here, and there are 3 slots before you see another A, right? A is here, then there's 3 slots, idle or not, before you see another A. I hope this makes sense. We do it again, idle time, the same formula. And we keep doing this until we have evaluated everything. We're considering Y next, the last one. And then once we've evaluated everything, we just say, okay, how many tasks were there in the first place? That's the length of this array, plus the idle time we have remaining, because you notice it was systematically dropping. We used the previous idle time. At one point it was 4, started out at 6, became 4, became 2, then became 1. Became 1 over here actually. And we were done, right? After we're done evaluating Y, it became 1. And so the total time is number of tasks plus the idle time. And this is just a visualization. It's not part of what we're supposed to do for this problem. I think we can hop to the code now. All right, this is the code in TypeScript spelled out. Start the debugger. We've populated the frequency. So we're dealing with this series of tasks, A, B, B. And the cooldown period is 2. We have these variables. A. All right, so we have a frequency actually. I think, is this the one? Oh, okay, we're already in this callback. But let me step out of it so we can see some things. Okay, so we have frequencies that we're not going to be using actually. It's just the initial map of all the tasks and how often they occur. So we know that A occurs twice, B occurs twice. Then skip idle time, skip max frequency. This is our cooldown period. The sorted frequencies, this is how they end up being sorted. You get the value, it's like how often it occurs, the value, how often it occurs. And the maximum, again, is that formula that we saw in the beginning. Actually, no, this is the maximum frequency. So basically, since this is sorted, it's just the last one, this value in here, and that's what we're doing. That's how we store the maximum frequency here. We then pop it, again, because we want to step through everything one by one. So take the largest thing out and then compute the idle time. And this is just how the maximum possible amount of idle time that you need. And you get it by this formula. You need to know this formula, otherwise you can't solve this problem. At least most efficiently anyway. Might need to be fact checked on that. Okay, so this is the loop that's gonna run through everything, pop everything in the sorted frequencies one by one, and update the idle time till it's done. And then when the idle time is done, we do the task length, the original task length plus whatever idle time we have left to get us the value we're looking for. And let's step through it. Up notes, let's keep track of the idle time. Okay. So let's watch the idle time. See, it's 2 right now, but it's going to change to 1. Again, you need to know this formula. The maximum frequency minus 1, and the sorted frequency is the next most, that's the current frequency, basically. What we called current frequency here. That's what's here, what it's being compared to. Then we evaluate the next one, which is, let me hide this, which is oh, actually, I think it's done because the length is not greater than 0. We're actually done. Break out of it, get the idle time, return the task length. That's it. So yeah, that's just one example. I can step through this other one quickly, if you can pay attention to it. When I break out of this loop, or no, I think it's fine. This might be a confusing end, but I'm going to call it a day here. I hope it makes sense. I hope it does make sense. Those formulas are essential. You can't solve this without like getting this formula out. And realistically, in an interview scenario, if you've not seen this before in your life, there's almost no guarantee that you're gonna derive this formula. It's a simple formula, but there's almost no guarantee you're going to derive it. So it's just best to be aware that it exists and let it sit in your mind for your intuition to grab a hold of it so you can recall it a lot easier. And then, of course, the big O of n is linear time because it increases as the computation you need to process it grows linearly with the number of tasks that you are given. And since we only have 24 letters in the English alphabet, the space complexity is O of 1. Thank you very much.